let's invite Professor Wang to share about our project on the algorithm side of this study. Thank you.
How do I do this? Oh, okay. Okay. All right. So, 我们用英文还是中文？
英文。
英文。
Yeah.
Okay. So let me can we put on the transparency? Yeah. So Julia already mentioned I'm not an expert in medicine. So I'm actually a mathematician, applied mathematician, and I did my own work also in machine learning and data science. So I want to tell you a little bit about how I got into this project. Okay, so one day Julia actually and Peter came to me and mentioned this particular project for breast cancer early detection using wearables. And they mentioned that they would like to seek collaboration on the part of early detection algorithmic part, because they know, I mean, Julia knew very well, none of us were, medical scientists, right? But I was, of course, in the beginning, I knew nothing about it. Then both Peter and Julia gave us an overview, and I immediately became very interested. Okay, so even though I didn't really have much the medical background, of course, my wife is a doctor, so she knows a lot about medicine, and the application of machine learning and data science, the major area of application, one of them at least, is in medicine. Okay, so this we all know that this has to be the future. It's not just medicine technology itself, but also the integration of medicine, mathematics, and AI, and every IoT. Okay, so we began to look into this, and we had, as Julia said, we had some test samples, a small number. So we also start trying to see what kind of algorithm we could develop. If we can have more data, we compare with other projects where we also have a limited amount of data. Okay, so this was the motivation for us to consider this. So I'll quickly go over, for this particular it doesn't seem to work. So how come? Use? I don't see it. You can close it and reopen it, probably. Yeah. Okay. Okay, now. Oh, okay. Yeah. Okay, good. This is good. Okay. So I think Dr. Zhou already mentioned about the the breakdown of each of different cancers, and mentioned that breast cancer is actually the biggest killer now. Certainly, even you count men, it's still the biggest killer. Is that right? Yeah. For women, certainly. Okay. So I just finished a comprehensive physical myself. I was glad to see Dr. Zhou's comment saying, man only got breast cancer like 1% or something like that, right? So I did not pay the money to do that part, okay? But anyway, this was, I was, still, I want to say that when I did the comprehensive physical, I had to go through a lot of procedures. I did an MRI, I did CT, I did ultrasound for different parts of my body. And it was a very time-consuming process. It's also not cheap. I mean, I think in China today, MRI the price has been significantly lowered, but not in Hong Kong. Hong Kong, we're talking about 9,000 Hong Kong dollars for an MRI. In China today, it's 800 now. So it's getting much more affordable. Still, you have to go to the hospital, you have to make an appointment, so it's not as easy. And then for everything else, like stomach cancer, you have to do quite a lot. Okay, so clearly there is a big need for using non-invasive, convenient wearable devices that can accurately predict, or at least, according to the data we've shown, to be able to give you a very good idea whether you should be alarmed. Okay, so I think this is the goal of this. Of course, later, I hope that Julia, the device with more data coming can even be used for clinical purposes. Okay, but that's the ultimate goal. But at least I think for the beginning, it will be good to make this a very valuable, perhaps a supporting device. Okay. Okay. So I already mentioned these are, you guys are expert. I wouldn't go over, but I did. Well, I don't do this, but I did all. I never did this, but these two just a few days ago I went through. Okay. Yeah. I found this these particular figure you mentioned, Dr. Zhou, you mentioned in the U.S. early detection was more than 40%. I mean, late, no, 60%, right? And for stage 3 or more, in China, it's already 80-some%, but in the US, it's less than 40. What was the reason for that?
Because in the US,
they do a lot of mammograph.
Yeah, the screening program has a large coverage.
Yeah, yeah. I think this is actually a way to, for me, this is not acceptable. Okay, we do have these kind of technologies, and even going to hospital for MRI now is utterly affordable. Okay, so of course, with the hope is with this kind of technology, wearable technology, we could do this significantly lower the rate percentage of late stage discoveries, possibly to less than 30%. Okay, I think that's utterly doable, judging from the data you guys have already performed and we have looked at it. Okay, yeah. And I already, I'm not an expert here, but Dr. Zhou gave a very good summary of what's happening when you develop breast cancer. And I also, I think as an outsider, I did ask a good question according to Dr. Zhou about the Warburg effect. This is something I actually read a little bit, so I was very happy you actually told me about it. But I think there's one thing I want to point out, that all these effects are, theoretically they all exist, but the signal sometimes is actually very weak. Okay, and how do you extract the signal from a lot of noise? Okay, I think this is exactly the kind of work we do. Right, using state-of-the-art machine learning technologies. Okay, we could do that. Okay, and I'll give you some, maybe not in the slide, but I will mention something to that effect. Okay. And the design and the position of the sensor and the design of the whole system has already been mentioned by Dr. Zhou, so I won't spend that much time on this. Okay, and this is essentially the flowchart for us. Okay, so the first step is, of course, data collection and plans cleaning. Okay, so lots of data you can collect. Many of the data are probably only serve as noise. Okay, so how do you clean up the data? That's also very important. But I think more than anything else, you need to have a scientific design of the kind of what kind of data you want to collect. Okay, So so this is the first part. And once you have selected the data, of course, you need to consider what kind of feature you want to select. Okay? And because different people have different environment, they are physically different. There might be some interference, like misplacement, and when you toss and turn in bed, and also the regional, temperature. You may have air con, you may not have air con, all kinds of things. So the data will inevitably be very heterogeneous, uh, genetic. Okay, so that means you have to find a way to reduce the heterogeneity of the data to make it actually work. Okay, so then of course the later would be we will need to build a machine learning models, and then finally hopefully with enough testing data and training data, we would be able to make this a very useful and a very effective model. Okay, so that's the okay. So what we're doing? Okay, right now we have 200 data. Okay, not enough. Okay, so we all know it's not. We need to have more data, and right now we set our goals for 1,000 data. Okay, now so today most of you hear the talk about the big data. AI, big data, and everything. So the amount of data was absolutely astronomical. Right? So for example, if you do images, we're talking about billions, possibly images. Okay, for training, for facial recognition, it's all about data. But in medicine, you just cannot have this kind of data. Okay, so this is one of the challenges. How do you develop a effective model, using a small amount of data? 1,000 data in AI is considered to be tiny, but in medicine, it's already for this kind of research, it's already a lot of data. Okay, I have previously been involved in using EKG 500 also. Okay, so for this kind of bio study, medical study, having 1,000 data points is already a good beginning. Okay, now of course, as you develop the typical scenarios, as you continue to improve your system, you're going to have more data because, of course, when people begin to use it, more data will be collected. So once the first prototype system can be used, you will see a dramatic increase in data. So I'm not too worried, but I think in the beginning we do need to have 1,000 cases with the BI-RADS defined by MRI. Okay, and of course there are 5 groups which Dr. Zhou also mentioned, and these are we'll need to identify 200 cases for each of the group. I mean, the first group is really easy. Okay, it's very easy to get, but for clinically, of course, when we already have some group 4 and group 5, group 3, group 4, group 5 data. The reason for that is only when you are shown to have a problem, they ask you to do MRI, to do a biopsy. Okay, so that's when people go through MRI, it's already being viewed as you're in a risk group. Okay, of course, if you're totally negative, nobody would ask you to do MRI. Okay, so that's why there's a bias here. But this, in the beginning group are actually the easiest to obtain. Okay. Anyway, so feature selection, actually, Dr. Zhou already showed some images. The main thing we need to be aware of is most of these bio signals are not very strong. Some of, if you're lucky, you get very, very strong signals. signals. Okay, it's like having, you know, sometimes you have very strong signal. Like if you have a big atomic bomb being explode, you know there's a war going on. Okay, but if you hear, you know, places like Chicago, you have some gang fighting each other, you probably don't see much signal until one day you read, you have, you know, you see somebody actually getting wounded or something like that. Okay, so what I discovered in this kind of research, our team discovered is signals are often weak, but they're strong enough to be extracted. I give you one example. I actually one time helped one of the wearable companies working out an algorithm to accurately calculate your heart rate. You know, you think this is very simple, right? But actually, in the beginning, it's not that simple because when you look at just purely from the data they send you, because they use green light to detect the blood flow change. Okay, it's actually very noisy. Okay, and furthermore, you can take, I don't know what's the technology today, but 6 years ago, you take this, put it on, and if you just move your arm, you're gonna get a very different reading, right? So obviously that's not correct. And the reason was because there was huge variations in the kind of data you will be able to collect. Okay? So all these require some kind of careful selection of the features, and the feature selection often can be done automatically, but occasionally, you know, especially for these nonlinear type of features, sometimes, you know, a little bit of human input inside, physiological insight would actually be very, very helpful. Okay. And the models is the other thing. Okay, so if we have 1,000,000 data points, I think anybody can build a model. Okay, I mean, you can use a standard, just take even the neural network models. You know, they take a convolutional neural network, it's probably just going to do it. Okay, but what we discovered in our other research related, not on this one, but previously we did the heart, you know, cardiovascular disease model. What we discovered was for this kind of data quantity, I mean, data set, it is actually the uh, the current state of the technology using neural network is not the best, okay? Simply because you don't have enough data. And instead, some of the other other techniques predated neural network. Well, I won't say predated neural, because neural network was one of the first models to be developed in the 1950s, but never took off because it didn't have the computing power. But before the mass adoption of neural network, people have tried many different other models, like PCA, for example. In fact, one thing we have been using quite often is the support vector machine and people using random fields and you know, different statistical model and you know, VAE, variational autoencoders, and that type of thing. Okay, but what I'm saying is, even for data set, a data contain 1,000 data, you can do very very effective machine learning. You know, it's of course, as you add more data, it becomes more and more accurate. In fact, with more data later, you know, when the data reach certain point, you probably would use neural network, but that's only after you have accumulated, say, you know, maybe 20,000 data or something like that. Okay, but for the time being, even with 1,000 data point, you can do a lot. You can be highly effective. Okay, it's just the confidence level will still need to be developed. okay? The more data you have, of course, the more confident you will be. And eventually, if you want to develop this into a, with a clinical tool, you would have to have far larger data. But that's, that's of course the ultimate goal. Okay. And we are, certainly we will have follow-up studies, okay, with 500 volunteers after we develop the model, which Dr. Solo also mentioned. Okay, so these are some of the things we will do, and I think that's the last. But I do want to mention another thing is going back here. Going back here, 1,000 cases. I think collecting those is not difficult. It is not, but it does have to overcome a lot of hurdles in the sense that you have ethics, you have to observe. You also have policies you have to observe, and you do have to worry about data crossing the border. I understand that Hong Kong is now in discussion with mainland for some kind of, to allow data to be shared in the Greater Bay Area, for example. Okay, all these are, I think, will play a key role. But to me, a lot of people ask whether data can cross the border. To me, actually, that's not very important for the time, because even companies, every company is running into this problem. Data you collect in Europe, you cannot take it out to the US or to China. And same thing with China. Okay, so but you can always do computation within the local, because with that kind of data, the computational power required is not very high. So it's very easy to do local computation training to obtain the data. Okay, but I do hope that in the we have the audience here can participate and help with this, because I think it is I'm not in the camp, so I'm speaking from a scientist's point of view. Okay, I think this is a very worthy project. It can potentially save thousands of lives. Okay, and if we can all help in collecting some cases, maybe not, don't even have to be that many. If each of us can have some resources helping us collect like 100, okay, then that's already a very, very important contribution to a very worthy cause. Okay, so I'll end here. Thank you.
Thank you.
Yeah.
We have collected some questions from a few doctors before.
Yeah. Mm-hmm.
They would like to know, like, how is our API technology developed?
I think this is probably not a problem at all. I mean, for this kind of technology, it's very, very easy to make a interoperable. You can have web-based, you can have, mobile-based, and you can have, basically that's not this part is the least worry in my, okay. Yeah, it's really the least worry.
So right now the system is operable in Hong Kong and in mainland China, that doctors is able to use the system on the patients for early warning.
Yeah,
the system is very smooth.
I think I guess I would conceive the following. Okay, so you will have servers. I mean, for early, you can have servers in China and in Hong Kong or wherever you go to. So because it doesn't require a lot of computing power. Okay, but eventually I think it's going to be local. Computing will be local. Local, then only the certain the data after processing, which obviously, I mean, which would not have as much privacy concern, will be sent to monitoring center to say, oh, you need to pay attention to this, okay? Because somebody has to read the data to tell you whether you need to be, or it can be just by, a direct recommendation on the device for the person, say, you need to see a doctor immediately. Okay, so I think that's the easiest part. Yeah.
I guess at the moment, the server from China and Hong Kong, let's say the international side, are separated.
Yeah.
Okay, so the patient's data and privacy are all well protected.
Yeah. You have to do that, right? Yeah.
And then as we say that the doctors have access to the patient's data, provided that the patient give the consent form.
Yeah.
And the doctors is able to read from the results.
Yeah.
And identify the high risk people, and then urge them to do further clinical testing.
Yeah, my hope is eventually, once we have people wearing this device and maybe coupled with other tests, I do believe, for example, genetic test, right? I mean, you could certainly give another angle of assessment of risk. And I don't know, I mean, as Dr. Zhou mentioned, maybe we could even look at the glucose level, right, for different, so all these data will serve to enhance the accuracy of the model. Yeah.
Okay, Dr. Tsai?
Yeah.
Thank you, first of all. Very interesting. My first one is, what are the criteria of choosing these 1,000 cases?
But this is essentially done from the machine learning point. Okay, what you don't want to do is for each group, like we have, we have 5,000 negative, 100 this and 300 that. Okay, that's not what you want. So even if you have more data, let's say I may have 1,500 data, but they're not uniformly distributed. Okay, of course, it depends on the pervasiveness of each category. Okay, but typically you want to have a good distribution of how many are in each group.
So your initial collection is more than 1,000 cases.
It could vary because you cannot tell. Yeah.
The reason is that I look at group 5. Now, normally you don't expect a very high number right now. If you want to get 200 of the group 5, you may end up having to screen, I don't know, 3,000 of the negatives.
Okay, so doctor, this is a very good question. The way I've talked to Julia about it is you need to do the reverse. Okay, you cannot just say, let's ask people to wear, then find those. We say, yeah, you should go to MRI. No, this is the wrong way, because this would do exactly what you just said. You're going to have massive number of people who are negative. Okay, and only very, very few. You have to do 1 million probably to get 200 of these. Okay, that's not correct. So what we're thinking is actually working with medical centers for those who have already performed MRI, and before they do the biopsy, to ask them to wear for 20 hours. Okay, this way it will be more. In fact, this would have the opposite effect. In fact, we'll have more people like this and that. Okay, but that's a good problem to have because these are very easy to get. Okay, so yeah.
You have what they call data bias when you do this reverse.
No, we will have data bias because we would have more people in these, probably at least in the but we can always add more of the negative ones because these are cheap to collect. Yeah, yeah. And in fact, data don't have to be perfect. That's another thing. Okay, so of course I asked the ladies here to wear the device. Of course, some of them may actually be positive, but we think they are negative because majority of them, vast negative. So we probably will label them negative. Okay, of course, and so you're going to have noise, but this kind of noise is very normal for these kind of studies. Yeah.
I was actually going to ask either you or Dr. Chow is that in your grouping of patients, there are some, I'm sure, have been treated. Are you going to exclude them?
I think this would, for the time being, for the time being, we consider excluding those, because once you have been treated, everything has changed, right? Even it's not clear to me, but Julia and Dr. Zhou have advised that we even should exclude those who have already done biopsy, although I'm not sure whether this should be, yeah.
Because my understanding is that when these devices were put out, patients who had already been treated or has been already diagnosed as at least stage 3 or 4 are not suitable for using these devices.
Yeah, I would suggest so, because they have already been, you have already gone, interference
Yeah.
to change the physiological signal.
The only comment I can make is that given this 1,000 cases as a proposal, we may end up with 3-4-4 of this number to satisfy a relatively even distribution of the 5 groups.
You can always select, manually select. I'll give you one example of unbiased data. Biased data the kind of problem it can cause. In the 1930s, there was a massive survey in the US conducted by a magazine called Literature Literature Review or something like that. Okay, so it took a lot of survey, tried to predict who would win the presidential election between Franklin Roosevelt and this guy Landon. The data they collect showed this was the largest survey poll done in the history of the U.S. with over, I think, like 400,000 people returning their poll, and the poll suggests a decisive victory by Landon over Franklin Roosevelt. But Gallup at the time took another survey poll, and they only used like 1,000 or so data points, and they predicted a decisive victory by Franklin Roosevelt. And it turned out Gallup with 1,000 data point was actually, was correct. And so what happened was exactly the data bias. Okay, so this we would have to be really, really careful in making sure. So in the end, it was imbalanced data. That because when they send out all these surveys, they send to people with address, and often those who subscribe to the magazine, these are like, more well-off people. They didn't, sample those in the ghettos who didn't have an address and didn't, have basically didn't have money. Okay, but they all have one vote. So it was actually Gallup realized the problem, so they resampled. They did not collect any new data. They just took the whatever, this big sample, big poll number, and they selected with a non-biased way 1,000 of them, and they reached their conclusion. I think this is exactly the kind of thing we will have to do, because we may get more data in one area, and later, I mean, there are all kinds of mathematical ways to make this work. So that is definitely one concern, but it's actually not difficult to address.
Okay. I think for the MRI data, I just have one point. At this stage, when Professor Wang is leading the research team to do the first, let's say, really in this field, it's the first pilot study to compare the Barrett rate with our system.
Mm-hmm.
And it will be like open label,
Mhm.
so it's not blinded. So every group that recruited into these 5 categories, we already know their MRI results. Then it's included into the data set and
Yeah.
then train the data.
This is the reverse way I talk to Dr.
Yeah,
Tai. Yeah,
Exactly. So
Yeah.
later, maybe it will be a blinded study. It will be the next stage.
yeah,
Yeah.
that'll be the 500 follow-up study.
Exactly.
Yeah.
Exactly. So do we have any other questions? No? Thank you for your time.
Thank you. Thank you. Yeah, thank you.
And
Yeah, Dr. Tai, thank you.
Yeah. Thank you. We end this session today and we welcome you to contact with us in the future. Thank you.
Yeah, great. Thank you. Thank you.
Okay.
Let's see what's.